Traditionally speaking, we would see the top of a floating roof tank handled by heat wire or fire wire or some kind of heat sensitive wire or line detection system that would go around the rim seal, and they would use that kind of system that is damaged by the fire and thus triggering a signal in order to provide their fire detection for the rim seal. We're seeing an increasing interest in moving towards optical flame detection for providing coverage to tank fires, just because the flame detection from the optical flame detectors can be a lot more sensitive. It can respond a lot faster to much smaller fires, and the flame detectors don't have to be damaged in order to just trigger an alarm. They're also much more robust against damage themselves, in that you run into a lot of false alarms with heat wire or fire wire, where the wire is damaged by something else, and then you have to go up and replace it before the system will work again. With optical flame detectors, you don't have to worry about that. They can just sit up there for a long period of time, not have any kind of maintenance issues. But with this increasing interest in optical flame detection for large atmospheric storage tanks and floating roof tanks, we're seeing an increased interest in mapping, and you're applying mapping software to these applications and validating for people how they're going to get good coverage in these areas. And so it's worth looking at this particular application, because it is kind of an interesting application with its own interesting kind of challenges. So I have a model here where we have a 20-meter diameter tank and a 10-meter diameter tank. These are a little bit petite compared to some of the things that you're going to see in the industry, but they're good enough for demonstrating our purpose for today. And so I'm just going to double check real quick, and I can see that my roof on this 20-meter tank is at 12.538 meters, or about 12.54 meters. So I'm just going to want to keep that in my back pocket in a minute here. So the first thing I'd like to do is just set up a fire assessment folder that we're going to just call Big Tank. And I'm going to create my assessment area. And so I find that the easiest way to do this is just to draw it graphically and make sure I'm capturing the entire tank. And then I'm just going to change this to 12.54. So it's just going to be a couple millimeters above what I found the top of that tank roof to be. And I'm going to say show assessment volume. And we'll just change this to 10. And 5, just so it won't fuss at me anymore. And so I can see one of the first questions I sometimes run into here is, okay, so I have a square assessment volume and a round tank. And the catch here is that, just like with everything else that we do, what's going to control how we do the assessment and what we assess for coverage is going to be controlled not by the assessment volume, but by what I do for grading. So I'm just going to hide my assessment volume now that I've created it and I've shown it to you. And I'm going to control click on the tank roof. And I'm going to do what our first blush impression of this problem would be. And I'm just going to come up here and say grade, and you pick whatever grade you want. In this case, I'm going to go with grade C. And we immediately see a bit of a problem here, in that we are getting this grade bubble around our tank because of how HazMap normally tries to grade the volume around the equipment that we're grading. And this is probably a little bit less than ideal, because with our square assessment volume, if I put detectors in here and run this assessment, I'm going to have the computer trying to grade and assess all this area outside the tank, which is not actually what I'm interested in. But there is a way to work around this. So what I'm going to do is I'm just going to delete this grade volume because I don't actually want it. And I'm going to go into my project rules, and I'm going to change the values in this inner distance column to 0. And then I'm going to control click and reselect my tank roof. And I'm going to say grade C. Now, because I have changed those values to grade 0, I am not getting any extent beyond the vessel, or 0 meters. So I'm just grading the inner space around the objects that I've selected, And that gives me this nice, clean grade volume around that tank roof area that I can play around with. So at this point I'm going to skip a bit, and rather than continuing with this assessment, I'm going to switch to one of these pre-made assessments you can see over here in my assessment hierarchy or my project hierarchy. And I have this one called 20 meter roof mount. This is the 20 meter tank roof mount assumption with 4 FDS 303 detectors. I'm going to make this my default, and I see my pre-programmed detectors I put in before pop up. And something to look at here being that I am going to have these detectors at a pretty aggressive down angle. In this case, if we look at the detector, I've set these to have a 30-degree down angle. The reason for this is twofold. One, having the detector like this makes this slope here very, very near the vertical. This is about a 60-degree down angle at this point on the bottom part of the field of view cone. So that minimizes this gap space that we're missing or that we're not going to see. This improves how much we're going to see near the edge of the tank with this detector. The other end of this is that because I'm angling this down so much, it limits how much above the other side of the tank this detector is going to see, and that's going to limit how often we're going to get things like having the sun in the field of view of the detector. And depending on the manufacturer's recommendations, some manufacturers say you will have this at a 30-degree angle to minimize that sun in the field of view. Some will say at least 10 to 20. Some will allow you to go up to 40 or even recommend 40. But you want to make sure that you're following those manufacturers' recommendations. And if they allow you to go up to 40, it might not be a bad idea to use that just to minimize, 35 or 40, just to minimize how much over the top of that tank you're going to see. But that said, I'm just going to return this to 30 just because that's what I had before. And that's what the others are set to. And I'm just going to run this assessment real quick. And if I hide my grade volume from the display, I can see I'm getting an assessment of just that top area of that tank roof, nothing beyond the tank walls, and I'm seeing what my coverage looks like. And if I want to, I can hide all of my background models and see what all this looks like. And I can see on the bottom, because I've defined my Z elevation to start at 12 meters flat, I am getting a little bit below that tank roof where I'm getting red showing. If I want to fix that, I can just go back here where I had this 12.54 and update this to 12.54. Turn back on my models and reassess. And now if I turn back off my 3D model, I can see that I'm not seeing those red areas on the bottom. I'm just seeing green because I've sliced above, or just a couple of millimeters above the top of that tank in the model, and my red areas dropped from about 14% to about 7%, which I like. So something you might bring up for yourself here at this point is this assessment assumes that these detectors are mounted on the roof of the tank, and as the tank rises and falls, the detectors are going to rise and fall with the tank. That may not be the case. You oftentimes are going to see these detectors get mounted high up on the sides of the tank, and the roof is going to float up and down, and the detectors are going to stay high up. If that is the case, what you're going to want to do here, rather than grade just the roof area, this space just above the roof, you're going to want to grade the entire internal volume of the vessel. And what I've done here is I've made it to where I've split out this model into parts, and I can hide the roof. So I can open this up and remove the roof, kind of peel the top off. And then what I can do is just select the perimeter of the tank, select the sides of the tank, and make sure I have mostly all of it. And then I can say grade C, again with that 0 value set, so I'm pretty much just getting the internal volume of the tank and nothing beyond it. And then what I'm going to want to have is, rather than just have this slice that I had before, I'm going to want to use this assessment, where I've defined the entire height of the tank. And I'm going to want to keep that roof turned off. And now I can run an assessment. And now the really cool thing about this is that I can see if my roof is floating up and down, how is my coverage going to change with my layout as I have that tank rising and falling with a fixed detector position up at the top of the tank. This is something you want to know, and this is something you want to be aware of if you're applying optical flame detection with fixed detector positions on top of a floating roof. Another problem or another question you may run into is, what do I do if I don't want to assess the entire top or the entire volume of the vessel? At that point, something you may consider, turning back on our roof, is you can use the draw tool and go to Grades, Fire, Exclude, and say I just want to only look at the space that's on this perimeter area where I expect the rem seal to be, and I do not want to grade this inner ring here. At that point, I can just say Extrude Shape and set this to, say, 1.5 meters. And then I can click around the perimeter of the tank. And this doesn't necessarily have to be perfect, but hopefully it's going to be relatively close. And double click at the end, and I can create an excluded volume. And you can see I probably would have given myself an easier time if I'd just had my view in a more convenient location before I started this process, but that doesn't matter. I can just come back in here and fix my boo-boo by adding an extra extruded volume or excluded volume. So I've added these excluded shapes from fire detection to the middle of my tank. And so now I can come back to my roof-only assessment, which should be right here. And I can rerun my assessment. And now what I'm going to see, if I turn off my background model and turn off my grades, is I'm only getting that grading around the edge, around this rim seal. So I've excluded this space and I've cut out all that area where of course I'm trivially getting 2 out of N coverage, and it lets me look more in a more granular fashion at just that space around the rim seal. This also makes it apparent that I've got that space that's kind of in that lip that is graded, that is not excluded. And so I'm getting a lot of red grade underneath here. That gives me about a 33% area with no coverage, which admittedly is perhaps not ideal, but if we just know that that's what's going on, I can see I'm getting very good coverage out here. And I can go layer by layer. And if I want to, since I've excluded that lower space, I can try to turn back on my model. And since I'm not grading this area and grading down to this level anyway, at this point, I can find out that my higher level is at 12.88. And so I can set this to 12.89 and change this to 12.89. Save, rerun my assessment. And what I should find here is that's going to mostly solve my problem with all that red area on the bottom. And since I moved that up, just cut this back to 2 because I'm getting more into that top area, and so I'm getting above my grade exclusion. It's getting mostly better. I could chop this a little bit lower, but I'm just going to hide the top layer. But we can see how, because I got rid of most of that area below, I'm just seeing a little bit at the rim. It's kind of behind a lip. In our model, we can see that we've got this little lip here that's being given a 0 or a no coverage grade or result. And so that's why I'm seeing that residual red there. But again, if I'm just trying to provide coverage to this area, that's a very good coverage. And I can do the same sort of assessment with the excluded volume. I don't even necessarily have to change what I've done other than to go into grades, and I could use the script editor on these excluded volumes to drop the level of that volume down, make it taller. Instead of 1500, I could make this about 15,000, make it 15 meters tall, and set the elevation of the vertices down to about the 0 plane. So that's a little bit of a crash course on how you can use HazMap3D to grade the rim seals or grade the roof of floating roof tanks, getting around the fact that we have square or rectangular assessment areas, but a circular target that we're dealing with. And this can also be used for things like gantry turrets and other objects that are circular.